how's it going? In the previous video, we got our camera set up where we've got horizontal and vertical looking, like pitching and yawing, and we still needed to do strafing. That is, when we look around and we move, the movement is not taking into account the camera's direction. Let's do that now. Now, a bit of warning, there is some math involved. Cue Steve Carell from The Office. No, good God. Come on, it's not that bad. Okay, so what I'm going to need to do is I'm going to need to also take in the camera's Oilers. Okay, and I'm going to need to get some directions. So I'm going to need two fundamental directions, my forwards direction and the direction to my right. And just for convenience, I'm going to turn these all into radians as well, because that's what sine and cosine require. So I'll have theta in the forwards direction. And actually, you know what? I changed my mind. I'm going to do this one bit at a time. So I'm just going to worry about the forward stuff. So in vector math, in trigonometry, in life, we've got an angle, and that angle decomposes into two components. It decomposes into like an x component and a y component. And the way we can do that is by taking the cosine and sine. So what I want is I'm going to get, let me say, cos of the forwards direction, just using the cos function. Okay. And then I'm also going to have sine of the forwards direction. So W is moving forwards, S is moving backwards. Now previously I was just changing my Z coordinate, but what I'm going to do now is I'm going to change both the coordinates, and I'm going to change them by the increment that we need to have in the X and Z components. So if I take the X component, its increment is... Now this might seem a little strange, and it sort of is. Now here's why. Because we're so used to thinking of X as just cosine. But if we have a rotation of 0, then we'll have an angle of 0, and then all of that movement will be, we want to be in the z-axis. On the other hand, if we were to transition that rotation towards 90 degrees or something, then we would be going from a movement in the z-axis to a movement in the x-axis. I mean, it would make more sense if I took 5 seconds and drew a diagram, but I'm going to do this instead. Let's go ahead and experiment with this. So we'll go down to the point where this is called, and in addition to putting in the camera's position, we'll put in the camera's Oilers. And the left and right movement is going to work the same as it did before, but if this is correct, okay, so I'll move forwards. Nice. With that, now let's work on our right movement. So again, we'll have theta right. And the way we will do this is just add 90 degrees to our forwards direction. Great. And now we can go in and do the same. So we'll take the sine of our right angle. Okay, so in all these cases, it's the same. The sine component modifies the x-coordinate. The cosine component modifies the z-coordinate, so forwards and backwards. And height is never going to change. So we're not going to go walking into the sky or something. So we can sort of give this a go. We can move around, and now we can sort of, yeah, walk around as well. I don't know, maybe it's, so this was throwing me a little bit, is that when I got close to the object and then I moved, it didn't quite, like the object seemed to be spinning around its own axis, which is very strange, but then for some reason does not appear to happen otherwise. I don't know. Maybe it's not worth worrying about. Anyway, so with that out of the way, we've now got a basic first-person camera. Very cool.